Well, welcome to 7.5, Roots and Zeros. Got a little squiggle line left over from something else. This section is kind of a combination of a bunch of things we've done. So here's the premise of this. If you have a polynomial that looks like this, now this is a big, huge equation. We don't know how to deal with factoring this. We have tools to factor quadratics. We have tools to factor some cubics if they fall into that pattern of a difference of cubes or sum of cubes. But we don't have any way of dealing with when the powers are bigger than that. So this is kind of opening up some possibilities to us coming up down the road here. So here's the idea. What you're going to do with a problem like this is you're going to get your calculator out and you're just going to plain straight up graph this thing. And we're going to combine a little bit of technology with some kind of plan work to be able to figure this out. And when I graph this thing, I get a picture that kind of looks like this. Now you got to have to take a good look at the window here, because look at this thing. If you put in 0 for x, you're going to get a negative 60 y-intercept. So look what I had to do to the y-axis to be able to see this. Now the x-axis is only going out here to 5. So I had to play around with this to be able to see what was going on. But here's what you want to see. Remember the title of this, let me go back. It's talking about roots and the zeros. And I'm also going to be looking at the factors of this polynomial. So to find these, notice where it crosses the x-axis. It crosses at 3 and negative 2. So the roots or zeros of this polynomial is x equals negative 2 and x equals 3. And what that means, if I put 3 into this equation, I'm going to get 0 for an answer. So f of 3 would be 0 and f of negative 2 would be 0. So if those are some of the roots, well, we figured out that before, if this is a root, then it must be that after you add the 2 to the other side, x plus 2 is a factor. Likewise, when I take the 3 to the other side, x minus 3 is a factor. So now I have two factors of this. Now remember what factors are. Factors are things that when you multiply them together, you get the number. So the factors of 6 are 2 times 3. The factors of 10 are 2 times 5. Now these two things multiplied together won't give me that because this is an x to the 4th power. So there's got to be some other factors. But what I'm going to do is take the factors that I know and divide them out. So I'm going to take this polynomial and I'm going to divide first by the x plus 2 factor. Now I'm going to use synthetic division. So if x plus 2 is a factor, that means x equals negative 2 is the 0, and it's the 0 that goes in this spot. So bring down the 1, the negative 3, 6, 2, negative 60, and I did the synthetic division. So bring down the 1 times 2 is negative 2, add those together, negative 5. Negative 5 times negative 2, positive 10, add them up, 16. 16 times negative 2, negative 32, add them up, negative 30 times negative 2, 60, and sure enough, smiley face here at the end, I got a remainder of 0. Well, if you do division and the remainder is 0, that means the thing you divided by goes into it or is a factor of it, and we saw that from the graph. So now I'm going to take the answer. I'm not going to go back to the original problem. That's a real key thing. I'm using that answer, what's called the depressed polynomial, because it's down 1. Remember up here, this was an x to the 4th power. This answer would be x to the 3rd power if I were to write it out. It's down 1 degree, so it's a, what we call a depressed polynomial. But now I'm going to do the division with 3. So the other factor was x minus 3, which means x equals 3, and that's what goes into the box right there. So bring down the 1, and 1 times 3 is 3, add them up, negative 2 times 3, negative 6, add them up, 10, 3 times 10, 30, and sure enough, again, a remainder of 0, which means that x minus 3 is a factor as well, because it goes into it. So what I've got so far is x plus 2 x minus 3. Now, when I did this division, let me go back. Look at what the answer was. I started at x to the fourth, then this would be an x to the third, and this answer is an x to the second. So that's 1x to the second minus 2x minus 10, and that's what I've got here. So now, last thing to do is take this quadratic, because we've got ways of dealing with quadratics, and I'm going to plug it into the quadratic formula and solve for x. So when I did that, plugged in opposite b, minus 4 times a times c, and I end up with a negative. I got a little lost in here, but that's negative 36 under the square root. And square root of negative 36 would be 6i. Everybody gets divided by 2, and you end up with this. Just like I did with the x plus 2 and the x minus 3, when I had x equals negative 2, and I brought it back over, I brought the 1 back over to the other side. So when you bring the 1 back over, it becomes negative 1. When you bring the plus 3i back over, it becomes negative 3i. And again, for the other one, bring the 1 back over to the other side, and that would get you negative 1 still. But now take the negative 3i back over to the other side, it becomes plus 3i. So what I have found are the roots, these guys, and the factors of that polynomial. So the final answer would be, depending upon what you asked for, what I asked for, these would be the factors. If you multiplied all of that together, you'd get that original polynomial. Or, if you want to know what the zeros are, it's that. In other words, take this, set it equal to 0, and each one, for example, x plus 2 equals 0, which means x equals negative 2. That's where this comes from. And you could do that with all 4 of those to end up with those answers. So zeros and factors are the same thing. They're the x-intercepts, and the factors, I'm not sure if I said that right. Let me say that again. The zeros and the roots are the x-intercepts, and the factors are the things that multiply together to give you the original polynomial. Let me know if I can help you out.